everybody, in this video we're going to learn how to do division algorithms for other bases. So let's start off with number line division. And remember, when you're doing division, there's two ways you can think about it. You could think about this problem as being 5 things being split up into 4 groups where there's an equal number of things in each group. Or you could think about it as having 5 things that are split up into groups where you have 4 things in each group and you're trying to figure out how many groups you can make. So when you're doing number line division, it's easiest to think about it as measurement division. So we're going to say, okay, well, let's say we're at 2, 5 on the number line, so we're right here. If we do measurement division, we can basically say, okay, well, how many groups of 4 can we create from this amount? And we can do this by doing repeated subtraction. So I can go back 1, 2, 3, 4, and that's one group of 4. Then I can go back 1, 2, 3, 4, and that's another group of 4. Then I can go back 1, 2, 3, 4, that's another group of 4, and 1, 2, 3, 4, there's another group of 4. And so 2, 5 divided by 4 equals 4 remainder 1, because you have 4 groups of 4, and then you have 1 remainder that couldn't fit into either one of the groups. So now let's do long division. And if we're going to model this with base 6 blocks, I'm going to use the sharing model of division, where I'm going to take the number I'm dividing and split it up into 3 groups. So I can visualize the number I'm dividing with 4 36 plates, 5 6 rods, and 2 units. And I'm going to split this number up into 3 equal-sized groups. So I'll start with my largest place value, and I'll say, okay, well, if I have 4 plates and I divide them up equally into 3 groups, I have enough to put 1 plate in each group. So I'm going to put a 1 in that place value. And when I did that, I used up 3 of my plates. So I'm going to subtract 3 plates. And that leaves me with 1 plate, 5 rods, and 2 units. Then I'm going to take that plate that wasn't able to be split up into the 3 groups, and I'm going to exchange it for rods. So now I have 5 number of rods, and I can split up those rods equally into my 3 groups. So when I do that, let's see how much ends up being in each group. Okay, awesome. So we end up with 3 rods in each group, and that used up 3 times 3 number of rods. So I need to figure out what 3 times 3 is. And I'm going to think about this as 3 times 6 divided by 2, because that's a helpful thinking strategy for this. And 3 times 6 is 30. If I divide that by 2, that's going to be 1 rod in each group, and then a half of a rod, which would be 3. And so I'm going to subtract 3 rods from the stuff that I need to divide, which leaves me with 2 rods and 2 units left to divide. So then my next step is to divide those up. So I'm going to take each of my rods and exchange them for 6 units. And when I do that, I will put 1 in each group and 2 in each group. I think I'm going to be able to put 4 in each group, but let's see. So there's 2, then 3, 3, and then put 1 more. Yep, it looks like I'm going to be able to put 4 in each group. So I'll put a 4 in my answer. Then to figure out how much I need to subtract, I'll do 4 times 3, which I'm going to think about as 4 times 6 divided by 2. So 4 times 6 is 40, divided by 2 would give me 20. So I'm going to subtract 20, which tells me that I have 2 units left. And so that would be my remainder. And so 452 divided by 3 in base 6 would be 134 remainder 2. And this is using the sharing model of division, where we take our number and split it up into 3 groups and figure out how much is in each group. But there's another model for long division where you can use measurement division, where we're going to take this number and we're going to divide it up into groups of 13 and figure out how many groups there are. So for this one, I'm going to say, okay, well, if I have 5, 3, 1, I definitely have enough to make 6 groups of 13, because 6 groups of 13 would require 1, 3, 0, because 6 times 1, 3 would be 1, 3, 0 in base 6. So this amount is going to be 6 groups, or 1, 0 groups of 13. So I'm going to subtract that, and that gives me 4, 0, 1. And again, I have enough to subtract 1, 3, 0 again, so I have enough to make another 6 groups. And 1 minus 0 is 1. I can't do 0 minus 3, so I'll borrow from here. And if I have 6 minus 3, that gives me 3. And 3 minus 1 gives me 2. Then I can subtract another 6 groups. And when I do that, that's going to give me 1, 0, and 1. And so now I don't have enough that I can make another 6 groups, because I don't have enough for 1, 3, 0. But I can subtract individual groups of 1, 3. So I'm going to take my 1, 0, 1, and I'm going to subtract 1, 3. So when I do that, I can't borrow from 0, so I'll borrow from here, which gives me 6. When I borrow 1 from there, that gives me 5, and I get 1, 1 minus 3. So if I do 1, 1 minus 1, that's 6, or 1, 0, and if I subtract 2 more from that, that would be 4. Then 5 minus 1 is 4. So 101 minus 1, 3 is 4, 4. And this is representing one group of 13, or 1, 3. And then I'll subtract 1, 3 again. 4 minus 3 is 1. 4 minus 1 is 3. Then I can subtract 1, 3 again to make another group of 1, 3. So I can't do 1 minus 3, so I'll borrow and do 2 and 1, 1 minus 3. So 1, 1 minus 1 is 1, 0, or 6. And 6 minus 2 is 4. And so 1, 1 minus 3 would give me 4. 2 minus 1 would give me 1. And it looks like I have enough to subtract one more group of 1, 3, which gives me a remainder of 1. And so what this tells me is that I have 1, 2, 3 groups of 6 groups. And so I'll have a 3 in my 6 column of my answer. And then I have 1, 2, 3, 4 groups of 1, 3. And my remainder was 1. And so my answer will be 3, 4, remainder 1. And that's how you would use repeated subtraction to solve a division problem like this. So if you have any questions, let me know. And I hope that you guys have a good day.